We're going to keep exploring derivatives of kind of more common functions, and the next type of function we're going to look at are exponential functions. So you're going to see in this video, we're going to get some base ones down, and then we're going to have to return to them for more complicated reasons. Okay, so we have an exponential function of the form a to the x, and a has to be, a positive number different from 1. And so if we begin by finding, or to find its derivative, we begin by using the definition of the derivative, right? So f prime of x would be equal to the limit as h approaches 0 of f of x plus a, which would be a to the power of x plus h, minus f of x, which is a to the x, all over h, okay? And let's see, if I play with this a little bit, play with the algebra, limit as h approaches 0, this would be, I could break this sum in the exponent up as a to the h, and then times a to the x, minus a to the x all over h, okay? And actually I could factor out the a to the x all the way outside the limit, because the limit is dependent on h, so anything containing an h needs to stay in, but everything else can come out if it doesn't have an h in it. So what I'd be left with inside the limit would be a to the h minus 1 all over h, okay? And what I need to do at this point is kind of scratch my head a little bit, but if I think about this carefully, what this would be is f prime evaluated at 0, right? Putting in 0 into the exponential function just gives 1, right? And so that's interesting. So what we're saying is that the derivative of a to the x would be a to the x times f prime of 0. And so this is kind of a little interesting. But we'll talk about this in more detail, but we will see that in general, when we differentiate an exponential function a to the x, we get the derivative as a to the x times ln of a. Okay, so we'll just kind of connect the f prime of 0 to ln of a later on in the course. So asking you to take this on faith for the moment. And then consequently, if a lot of times with exponential functions, we don't necessarily look at a to the x, we look at e to the x with the exponential number e. And so then if you run that through, remembering that ln of e is 1, we just say e to the x is e to the x. The derivative of e to the x is e to the x. But then really just later on, I can't stress this enough, if you have something that isn't x in the exponent, right? So if you have an f of x in here, what we end up saying later on is the derivative of e to a function of x is e to the function of x times the derivative of that function. That's called the chain rule, and we'll see it more in upcoming classes, okay? But I digress, okay? And then also we can sort of make this connection because of what we saw before, right? That the derivative of the general exponential function is a to the x times f prime of 0. Then what we're really saying is that if we need that to be 1, since the derivative is just e to the x, that we can say e is this special number. That makes this true. That's kind of fun. It's another way to define e, okay? And so more to the point though, like how do we use this information? Well, we gotta, do some derivatives. And so we wanna figure out, on what intervals is this function increasing? Okay, so again, increasing means that the derivative is positive. Okay, so then I need to find the derivative. Okay, differentiate this. So 5x's derivative is just 5. Oops, don't want that. Is just 5, and then minus, and the derivative of e to the x is e to the x. So this has to be greater than 0. Okay. Again, if you want to go forward with this route, you sure can. I prefer to do it as equal to 0 and analyze it completely. And so I would say 5 is equal to e to the x, and then converting it from exponential to log form, I'd get ln of 5 is equal to x. And then what I would do is look at the number line. So natural log of 5 would go on my number line, f and f prime, and then I would do sample points. So maybe like f prime of 0, and then natural log of 5 is a number. I'm going to do something large. Let's do f prime at 5. Okay, so f prime is 0, put that through here, that'd be 4, so that's positive. So that means the function's increasing. F prime of 5, so 5, let's see, that'd be like 5 minus 2 to the 5th. 2 to the 5th is a large number, a large positive number, so that's going to be negative. So I'm going to say it's decreasing here. Okay, so then my answer here, where on what intervals is it increasing? I would say f is increasing on the interval negative infinity to natural log of 5. Okay, and here I didn't actually, again, sometimes you might have to pay attention to the domain. Right now we're working with all sorts of nice continuous functions on all real numbers, so we don't have to worry about those. But again, you might have to restrict the interval based on the domain of the function too. So just something else to be aware of. But in this example, all that we really did that was new was remember that the derivative of e to the x is e to the x, and then had we had something that wasn't e, the derivative of that exponential function would be a to the x times ln of whatever the base is, ln of a. Okay, so make use of this rule too as we progress forward.